Hi, this is my lab presentation for Lab 2, Lines of Charge. So the key objective of this lab is to model each tape as a collection of point charges when placed side by side in a line. This is something that we viewed in class, and so the point was to explore this concept and understand it through a real-world example. And the purpose was to ultimately calculate the magnitude of the charge of one piece of tape by using a more detailed computational model. So ultimately building on what we did in Lab 1. So just to start off, I want to point out the biggest difference, as I said, is that now we're separating the tape into a bunch of point charges. So the code seen below was given to us, and there it separates what represents the tape into multiple different points, which are the spheres. And so the concept of this lab is to then use each of those spheres to find the individual gravitational force and electric force, and then together find the overall forces. So some fundamental principles is that first, the superposition rule for electric field of distributed charges. This basically is the principle that you can compute electric field for each segment and then add it up to find the total given off by an object. So we see this when we calculate it by hand in the form of integration. However, the computer model will do this for us. Also, we use Newton's second law, which, as in Lab 1, the magnitude of the gravitational force is equal to the magnitude of the electric force, and these are in opposite but equal, so they're opposite directions. And also Coulomb's law, which helps us find the charge of an object. The procedure, again, starts off being the same as Lab 1, where we have two oppositely charged pieces of tape, which we create by tearing them apart and then hold one above the other in order to have it levitate without touching, and then measure this height. And now we're adding in treating the tape as a line of point charges rather than a single point charge. And a key thing to note is that the top tape is the system we are observing, and the bottom tape is part of the surroundings that's acting on this top tape. And at the location of each of the point charges in the top tape, there's an electric field that is produced that matches from the bottom tape. And so the calculations, this is similar, or basically exactly what I did in Lab 1 to calculate the electric field, and then the force of the electric field by multiplying it by the charge. I used the same measurements for this lab, and the values to the right are what I ended up putting in my code. And then as you can see on the left, from the first lab, when I calculated it by hand, I got that it worked out really well, where the gravitational force is equal to the force from the electric field. So then, now using the coding model, basically the biggest and most important part of this was the for loop shown below, where it used this loop to calculate the electric force at each point charge. And the reason there's two for loops is because first you're iterating through every point in the top tape, and then you're iterating through every point in the bottom tape, and then you finally, as you can see in the end, you do the plus equals to each time, add that onto this overall value, which is the Fe on top, which is the overall electric force on the top tape. And then the gravitational force is just calculated by mg, and here are my results. So when I split the charge up into actually 12 segments, it ended up giving me pretty close results, but not super exact. And yeah, you can see that the arrows, each of the green arrows is what belongs to the charges, but then the white and yellow distinguish the electric and gravitational forces. And overall, the assumptions were that each U-tape has the same charge. I had to neglect air resistance. The density of the tape was 1 gram per meter, and if I had modeled it as a single point charge, it would not be as exact, because the more segments you are, the more accurate it can be. And these are different because the overall, like in the first one, it's only one, and so it's less accurate, and then really it needs to be distributed over the entire length of the tape, which is like a bunch of little point charges, and the value from Lab 2 is closer to the real value. And that is the end of my presentation. Thank you.